We're now going to discuss modularizing our programs. And if you don't know already, it's really good practice to try and keep your programs as simple to read and self-contained as possible. And what I mean is, try and split up any large complicated tasks into much smaller, simpler tasks by placing each task into its own separate individual module that you as a developer are able to concentrate on without any other distractions. Modularizing your code lets you focus on that one single task and not get confused by the big picture of a much larger development that you may be working on. By working on individual tasks, it makes it much easier to develop and debug your programs. You develop individual modules of code that once tested and complete, you don't have to worry about again, leaving you free to concentrate on any other issues that may crop up in other areas of your coding project that you have to solve. Creating individual source code modules helps you avoid repeatedly writing the same set of statements again and again. And this in turn makes your programs easier to read and understand, both by you and by others. And a big benefit is when it comes to support. By creating these small modules of code, anybody having to support your programs in the future, maybe even you'll find it much easier to read and understand what's going on. And when you first begin to design your program, it's important you concentrate on the design. Do not start coding straight away. You need to map out your solution. Maybe use some pseudocode or maybe flowcharts, whatever you prefer. Only when your design makes sense should you then start turning your solution into ABAP code. Making sure you design your program first really helps when it comes to modularizing your program, because you can see how you can split your program up into separate pieces, which will allow you then to focus on the development of one piece at a time. Now, if you recall, when we looked at designing selection screens, we used modularization techniques by making use of processing blocks, such as the start of selection block. Modularization isn't just limited to using processing blocks in our program. The SAP system itself allows us to use a number of techniques for breaking our program up into smaller, more manageable pieces of code. And throughout this section, we're going to take a look at just how we can modularize our programs using the various tools SAP provides. What we're going to concentrate on first is something called source code modules. Now, when we talk about modularizing our program, all we mean is we are going to take a sequence of ABAP statements from our program and place them in a separate module. Then in our normal ABAP program, we just call this module. Let's get straight down to the coding and have a look at how we can modularize some of the code we have used in previous examples. Here we have one of the previous examples, and I've modified it just a tiny bit just to tidy it up. And if we go through it, you'll get the main gist. And then we can start modularizing it. So first of all, at the top, with our table statement, we declare some types and some data. And then we have our ABAP logic to actually do something, which is an array fetch, an individual loop, so clear statement, another loop where we modify an entry in the table, do an insert, and then a couple of read statements. First of all, we're going to look at using what is called include programs. Now, include programs are made available globally within an SAP system, and their sole purpose is just for modularizing code. They are very simple to define and accept no parameters. So first of all, just under the report statement at the very top of our program, let's fill in the statement to declare an include. And all we need to do is type include, and then we just define a name. So for this example, let's do Z underscore employee underscore definitions with a full stop at the end. Looks pretty simple, doesn't it? So what we're telling the program here is to include our include program that we've just named into our main program. And you probably worked out that we haven't actually created this include yet. So let's go ahead and do it. You have two ways of creating an include file. The first one, if I open up a new session and bring up SE38 again, you can key in your include name. I'm not going to do it here, I'll just do Z example. But instead of saying source code and you create your program, you're going to create program attributes. So here we just give it a title. And when we come down to type, instead of choosing executable program, we would choose include program. And then fill out the rest as we normally would. Now the second method is something I'm sure you're familiar with already. Oops, I'm jumping the gun. And that's by using forward navigation. If you remember, we used forward navigation a lot when we created fields in our database table, and we've used it within the ABAP editor to go check out field definitions and so on. But we can do the same thing to create additional files within the ABAP editor. So all you need to do is, once you've typed the include, just give it a double click, and we get the pop-up box saying your include does not exist, you want to create it, and we say yes. Assign it to the local development class, and that's it, we've created it, and it gives us a blank program where we can put our code. I'm sure you'll agree forward navigation is a lot more efficient. Now from here, just to go back and show you just that it's the same as creating it through the SE38, if we use the go to menu and have a look at the program attributes, we'll choose yes to save. You can see it's exactly the same screen. It shows the include program. It's a test, it's assigned to basis, and there's our development class. Now remember, this include file or program is a separate file on the SAP system and can be included in any other program. So you have to treat it as a separate program, and you'll see that it's got its own check, it needs activating and so on. So let's activate this right now. Even though it's got nothing in, it should activate. And we get the pop-up box asking us what do we want to activate. It shows a report program, and it's highlighted our employee definition include already, so we just give it a green tick. And now it's active. Now if we step back, whenever we activate this program, our main one, it will automatically check to make sure our include program has already been activated. And if it has, this one should activate just fine. So include programs are really easy to create, and they help us in our development by taking away some of the noise from our main program and provide us with the ability to reuse our code throughout an SAP system. So this is great. We created our include, but you're probably thinking, well, we put no code in it, and you're quite right. So what we're going to do now, I'm going to take some of this code that we have here. Oops, wrong key. I'm going to take this, I'll comment it out, go to our include, we'll choose yes to save our changes, Click Change. And now all we need to do is paste our code into our include. I'll click Save. Now on purpose, I'm not going to activate it here. We'll step back. And I'll just show you, to actually use this code now, we need to activate our main program. And when we do it, we receive this message saying we have syntax errors, so we need to look at those. And it's telling us the line 01_typ is unknown. And this is because our include has not been activated. The system doesn't have an active version of that code that our main program can reference. So to activate your program, you can either go to your include and activate it, or when activating your main program, select your include as well. And that way you're assured everything will be active and all the data objects in this example get referenced appropriately. Now also, if we step back to this include and we'll make a change, we'll add an error in here. Let's just add letter N, for example. We'll step back. Now our main program is active at the moment, and that's only because it's using the active version of our include. If we were to do a code check again, you'll see that we've got this error message cropping up telling us our include program contains an error. Now this seems fairly obvious, but what I want to point out here is when we do syntax checks in our main program, it will also carry out that syntax check on the inactive version of your include. So they work in tandem. So let's go back in, we'll change this, get rid of this error. And then everything's back. So that's it. That's a very small example of an include program, but it shows you we've only put 4 or 5 lines of text in the include. You could put 200, 300 lines of code into that include file, which in effect helps you encapsulate certain elements of your program, pop them away in a separate file so you don't have to worry about them. And you'll see this type of thing being used quite often for both code, logic, and for data declaration parts of a program. Quite often people will create an include, put all the data and type statements in the include, and then just have the logic for the code in their main program. And that way, all the data declaration pieces can be used in other programs as well. Now let's focus on procedures. Now for those new to ABAP, there are a couple of techniques for modularizing code that you should really concentrate on. And that's what we're going to cover here. When we want to split our programs into separate modules, we can use what are called procedures. And procedures are processing blocks that we call from our main ABAP program. Now procedures come in the form of subroutines or subprograms and function modules. And we use subroutines mainly for local modularization of our code. And what I mean is a small modular unit of code that is self-contained, that is called from the program in which they are defined. So it's just like grouping together, let's say 20 lines of code, wrapping it up into a subprogram, and just moving it to the end of your program, right down at the bottom, still in the same file, but just moved away in its own little container. So we can use these subroutines to write functions that we use many times within our programs. And at the same time, any ABAP program can include subroutines. Now function modules, they work a bit different. They allow us to create modular blocks of code that are held separate to our ABAP program. And they can be called from any other program. So subroutines are local to our own program. Function modules are global and can be called from any program. you will see both sets of modularization techniques used throughout an SAP system. But by far the most used, in my eyes at least, are function modules. And an SAP system is packed with function modules. They encapsulate all the processing logic used within the business system. And SAP have made sure they can be reused both by their own development teams and by SAP customers. Now, when we took a look at include programs, I mentioned an include program cannot accept any parameters. Procedures are different because they have an interface for transferring data from our calling program to the procedure itself. So because we can pass data into a procedure, it also means we can define data definitions within the procedure itself that are only available to that procedure. So enough talking, let's have a look at how we create subroutines and see some of this in action. One of the great benefits of using subroutines is that it helps us modularize our program code inside our actual program. It helps give our program structure. So what we're going to do right now is have a look at how we can create these subroutines. Now there are a few methods, but what I'm going to show you is by far the easiest, and that's using forward navigation. And what we're going to do is pop this one select statement into a subroutine all by itself. So I'm just going to copy it to the clipboard. Then I'll comment it out just so we don't lose it. And then I'm going to use a statement called perform. Now the perform statement is what is used to perform a subroutine. And all I need to do in its simplest form is say perform and then create a subroutine name. We just make one up that represents the type of function we want to do. So in this case, we're going to fill itab02 with some data. So let's say itab underscore 02, actually there's no underscore, is there? itab02 underscore fill. Full stop, and that's it. Now of course, all we've done is type in the code. We haven't created it yet, so we will use forward navigation. So I will double click, and it says the subroutine does not exist. You want to create it, we'll choose yes. And then it gives us an option of saying, well, where do you want to create it? Now, we have the option of, we could include it in the include that we created, but you know, that include, maybe we just want to keep that for data definition, so we won't choose that one. It gives us the choice of creating a brand new include, and it's given it its own name, which we can change. But I don't want to do that. All I want to do is create this include in the main body of our program. So I'm going to choose this one, click the middle button, and then what the system does is scrolls right to the bottom of the screen and creates a form. It gives us some comments here, and then it allows us to enter whatever code we want inside the form. So what we will do is, because we have our code copied to the clipboard, I will just paste it in, and that's it. This code now belongs in its own subroutine that we have included at the bottom of our program. So let's do a syntax check. Everything is good and we can activate. So now it's active and we know everything is good. Let's just review it one more time. We created a perform statement and we're saying perform this subroutine. Now use forward navigation to jump to it. And then the subroutine says select all the records from Z employee into the corresponding fields of table itab 02. So the system will perform any code we put inside the form end form structure And then once the system encounters the end form statement, processing will be returned to the next statement under our original perform statement. So the next statement will be this loop statement. Processing will continue down to the bottom of the report where it will terminate. And please note, I'm considering this the bottom of the report. This is a subroutine. The system will not run through and perform this at the end. It knows this is a subroutine and doesn't class it as being part of the program at the very bottom. It's a separate subroutine in its own right. Now there's some other things to consider here. Up to now, we have worked with global variables only. And what I mean is, all the variables we have used have been declared in the header of our program. And in our case here, as well as being declared in the header, we've also declared them in the include. So going back down to our form, this will tell you that your form can access what are considered global variables. It can access all the variables. So in this case, we are changing the contents of a global variable or a global internal table, itab02. Now what we haven't discussed is the use of variables defined exclusively within our subroutine, which we would class as a local variable. Local variables can only be accessed within the subroutine where they are declared. Once the system finishes processing code within our subroutine and control passes back to the main body of our program, all the local variables can no longer be referenced. Now, some of the benefits of using local variables are that the variables only have to be available in the subroutine, so there's no point making them available outside. So by declaring them inside the subroutine, we save a little bit on memory usage. And because we are trying to modularize our code, by declaring local variables and using local variables, we don't have to worry about the variables being declared in the main body of our program. You know, everything is self-contained. Now, I mentioned a little while ago that subroutines have an interface, and we can use local variables in our subroutine to be used in the interface, and we can give them any name we want. And at the same time, the calling program, so in our case the main body, that can use its own variables as well. It doesn't have to use the same name that we defined in the subroutine. So to declare a variable in our subroutine, there's no magic. You already know the code. All we do is make sure we are inside the subroutine and we just start coding. So we would use the data statement. Let's say employee, if I can spell. Oh, let's give it a different name. Z employee. Z-E-M-P-L. How's that? And we can say it is like our Z employees table, the field surname. So here we have just defined a local data variable within the form, and it can only be referenced from the code we place inside the form, which we don't have much of just yet. Now I mentioned we can declare variables to be used in the interface of our form. And when we do that, we're telling the system we're going to transfer data throughout the subroutine data interface. So let's have a look at the code and see how we do it. So what I'm going to do is go back to the top of our program. Well, scroll down and we'll do another perform statement. So I'm going to say perform itab o2 fill, well, let's say again. But this time I'm going to say using Z field 1 and Z field 2. So what are these Z fields? Well, they can be anything at all. So let's say up here we have another data statement. We will say Z field 1. We'll say like Z employees. Let's say surname this time. And Z field 2, we can say like full name. So I'll just do a syntax check, make sure we got no errors. And we do. Let's have a look. Oh, of course. I haven't created the subroutine yet. Let me just comment this out. There we go. Okay, everything's good. So we'll put the code back in. And now we will use forward navigation to create this brand new form. It says, do you want to create it? Or choose yes. And we'll say pop it in our main program. And we're down at the bottom. Now, add a few spaces. Now notice how this differs. Because we declared this perform statement and added the using and added 2 fields, our form was generated and included 2 fields that will be used in the interface. So this is one of the benefits of using forward navigation. You don't have to think too hard about the actual syntax you need to use to create a form, because double clicking using forward navigation, it creates a syntax for you. But what I would say is rename the fields so that they are easier to understand. They represent what you're passing through. So in our case, I'm going to say Z surname. And I'm going to rename this to Z forename. Now something else to notice is the form here is declaring 2 fields that will be used in the interface of the form. But notice there's no data type. Now they were taken from our perform statement, so the fields used in our form are declared exactly the same as those declared in the main body of the program. When our program is executed and processing reaches the perform statement, the contents of Z field 1 and Z field 2 will be copied in to our PZ surname and PZ forename within the form. Now one thing to bear in mind is if we change the contents of our local fields that have been declared in the form header, so these 2, you will also be changing the values of the fields that were passed into the form by our perform statement. So let's add a line of code to see how all this works, and then we'll debug the code. So in this form, I'm going to say PZ surname. No, actually, what I'll do is write PZ surname on the new line. And I'll do the same for forename. Then I'm going to change the contents of surname and that's it. Now higher up in our program, where we have the perform statement, I'm just going to make sure we're going to pass in some values. So I will say Z field 1 is equal to Andrews. And Z field 2 is equal to Susan. So when the perform statement is executed, these values will be passed through to the form subroutine. So let's check our code. We have a missing full stop, of course we do. Okay, and we'll activate. And then I will add a breakpoint to the first perform. And then let's test it out. So the first statement, it says perform iTab02 fill. So let's step into this. You can see it's jumped down to the form. Let's have a look at iTab02. It's initial at the moment. So it executes the statement, fills the table, we reach the end form, and now processing passes back to the top of our program. We fill Z field 1 and Z field 2, and then we perform our second subroutine, iTab02 fill again, and we're passing in these two fields. So let's move these up a little bit. And here I'm going to bring in ZP name and Z4 name. So here you can see the values of Z field 1 and Z field 2 were passed into the interface. Or sorry, were used in the interface so that the local variables P underscore Z surname and P underscore Z forename were filled with those interface values. We then have two write statements, which we can see on the screen. And then we're going to update Z surname, or P underscore Z surname. And see what happened? Because the field is used in the interface, our global variable, Z field 1, was also updated at the same time. So this is a really important thing to keep in mind when you're using fields in the interface and you're using the using addition. Any fields used in this declaration will be changed as well. So let's zoom through, well, we'll step through. So once that form is filled, then it continues with the rest of the program, which I can't remember really what it does. I guess it's doing a loop. Let me stick a breakpoint here so we can zoom through this. Zoom through that. Simple describe. And then the program crashed. Let's have a look. And yeah, there we go. There's the problem. We have this clear statement, so the internal tables are actually empty at the time we try to insert a record. So here we should have some logic to say if line count, let's add that. If line count is greater than 0, perform our insert statement. And actually, let's include all this in this if statement. Looks good. So now when we get down to the insert statement, right now it shouldn't do anything because we have this clear. But if this was taken out, then the if statement would be true. Let's run it again. I'll press the F6 key to execute this first form fill. F6 again. Stick a breakpoint there. So we go through that loop. Cleared out the work area and internal table. So now this loop should actually not execute. There we go. Describe line count. If it's greater than 0, perform the insert. If not, then the program's finished. So a little detour into a debugging my error. But all examples are good examples. But that's it. That gives you a good flavour of how to use subroutines within your program. Now, we're not done with subroutines just yet. We're going to look at some of the other additions and how we can pass more than just fields through the interface. Subroutines are not only limited to passing individual fields. You can also pass internal tables, as well as a combination of individual fields and tables. Just remember, you've always got to get the sequence of fields correct when you're passing fields in internal tables from the main program to your form. Because it's the sequence of the fields when you create your perform statement that determine which field is passed to the interface variable of your form. So let's have a look how we can do this. So what I'm going to do is create a brand new form. Now I'll say, let's call this iTab2 write. We're only going to write out the contents of iTab2. And instead of having the using addition, what we do is include tables, followed by the table we want to pass through. So in this case, it's going to be iTab02. So we'll save our program. And then let's create our form by using forward navigation. We'll select to create the form in our program itself. And it gets created at the bottom. Now I'm just going to adjust a few things here. This code here is not actually needed, so we can remove that. And we'll just focus on the basic form of how it's generated our subroutine. So as you can see, it looks fairly simple, but there's a fundamental change that's gone on here. We have replaced the using addition with the tables addition. So now, when the program is executed, the perform statement ensures the contents of our internal table are transferred to the subroutine and stored in the internal table p-itab02. Once processing reaches the end of the form, the contents of the local internal table are then passed back to our global internal table. And just note, this is for a table without a header line. If we are using the older techniques of passing tables with header lines, then this perform statement structure that we have just declared up here would only pass the header line of the internal table to the subroutine, and that's not what we want. To be able to pass the whole table contents when using an internal table with a header line, you need to use square brackets. So the perform statement would look like this. But don't forget, I don't want you to be coding this way, so we always want to use work areas and internal tables without header lines. So let's go back down to our form and let's discuss the internal table that's created for us when the form was generated. Now, when an internal table is passed into this subroutine, this local internal table is actually always declared with a header line. And we can see this if we debug our program. So let's add some code. So we'll start with creating a data statement first, and we'll declare a temporary field. And don't forget, we already have our we have our line type already declared. So I'm just creating a work area here, the same as the line type for our internal table, which starting to type wrong, so I think it's this one. And then we can do a loop statement. Loop at p underscore itab 02 into WA temp. And we can write WA temp surname to the screen and end the loop. Let's pretty it up and do a check. Everything looks good. So now let's stick a breakpoint in here. Oh, sorry, we need to activate, of course. Then do a breakpoint. And we'll test our code. So now we have jumped straight into the form. We'll have a look at our itab 02 table. You can see it's got 5 records in, and we can see it's the newer style internal table because we got no header record. Now if we have a look at this P table, you can see here we got the hat sign, and you can see we have a header record. It's the old style. But being good coders, what we've done, we've made sure we have used a brand new work area when we're looping through our local copy of the internal table. So I'll just execute this as the output. Now let's take a look at how we can use a combination of fields and tables to be passed into a subroutine at the same time. So let's go to the top of our program. We'll create another perform statement. And we'll call this perform itab 02 multi. And here we can leave the table statement in with our internal table, but then we'll add in using, and we can use our Z field 1 and Z field 2. So you can see this is a combination of the first 2 perform statements, all combined into one, to allow us to use a mix of fields and tables. So let's generate this form. Here we go, and you can see the form has been defined. We have the table statement, and then we have the using statement for the fields. Now, as I mentioned before, if you are manually creating your perform statements, make sure you get the sequence of fields correct that you define. So, for example, if we had this, mixed around, Z field 2 going to Z field 2, then Z field 1, things would get mixed up, and we would be putting Z field 2 into this local variable and Z field 1 into this one. So you can see how it could create some confusion. So just keep an eye out on that. Subroutines were initially designed for modularizing and structuring your programs, but they can be extended so that they can be called externally from other programs. If your goal is to make a function available throughout your SAP system, you should really use function modules, which we will come on to very soon. But let's take a look at how we can create external subroutines and how it all works. So just like with any local subroutine, when the system completes executing an external subroutine, control is passed back to your calling program. There are 2 ways in which you can call a subroutine of an external program. And I'll say right now, try to always use the first form I'm going to show you. There's a very big reason for this, and that's when you come on to learning about ABAP objects, if that's what you choose to do, you have to use this first form. Also, in this first form, we can actually use variables to identify the program that contains our subroutine instead of hard coding the form name throughout our code. So let's look at an example. I'll create some blank space here so I can start coding. Let's say we want to call a subroutine called sub1 of a program called zemployee_hire. You would write the code as follows. You start with the perform statement, then we would specify our subroutine name. So in this case it's sub_1, and then we will specify in program and then the program name, zemployee_hire. And then as before in some of the other perform statements, we can pass certain variables by using the using addition. And finish with a full stop. So that would mean we would have to have a program called zemployee_hire already existing with this subroutine already in it. And we're just passing across these fields. And the difference between the standard perform is that we are specifically specifying the program where the subroutine exists. Now I said there were two methods of calling the subroutine in an external program. And the other way of doing it is by using brackets. And you will see in this example it's very similar, but you will not be able to use this form in the context of ABAP objects. But anyway, it goes like this. So you'd have perform subroutine 1, and then we specify the table, we specify the program by placing it inside brackets. And we can pass tables, just as we've done before, and continue with the using addition for the individual fields. So there are two methods of calling external subroutines, but I please advise you don't use this. I'm just showing you it for completeness and so that you will understand some ABAP code that you might see in SAP systems. I've got to say, I don't see this being used an awful lot at all. Nearly all the forms / subroutines that you will see are all contained within the main body of programs themselves. Very rarely do you see subroutines being called from other programs. And like I say, the best thing to do when you need to do this is to create function modules, which we are going to come on to next. Function modules make up a major part of an SAP system, because for years SAP have modularized their code using function modules to allow for code reuse both by themselves, their own developers, and by their customers. And function modules are just specific procedures that are defined within function groups and can be called from any other ABAP program. The function group acts like a container for all the function modules that logically belong together. For example, take all the function modules for your HR payroll system, group them together into a function group. Maybe there's a bunch of function modules dealing with cost center reporting. Well, they can also be grouped together in function module groups. SAP systems literally have thousands upon thousands of function modules that are available for you to use in your programs. So there is no need to reinvent the wheel all the time. Have a search around your SAP system to see if function modules already exist that perform the function you need in your program before having to create it yourself. Let's concentrate on how we can create function groups and function modules. And to do this, we're going to take a look at the function builder. So I'm going to step out of the ABAP editor and go back to the main menu in SAP. Now, way at the start of this course, I mentioned that the function builder can be found under Tools, ABAP Workbench, Development, and you'll see it here. And once you get used to the transactions, you'll also be able to call it up using transaction SE37. For our example exercise, we're going to write a program that uses an existing function module. But before we get on to that, we'll take a look at the function module we're going to use and explain how it's put together, which will then allow us to discuss how we can use it in our program. Now, instead of typing in the function module name, I'm just going to put part of the name in and use wildcard characters to do a search for the function module, just to help demonstrate really how many function modules there are and how you would go about searching out function modules yourself. So what I'm going to do is key in an asterisk and then key in the word amount, followed by another asterisk, and then press F4. Now this is showing me in this system, I do have some filters set, but there are 12 results that have come back. And what I specifically want to show here is we get the function module, which is in blue, but then we get the function group, which is above it. And we can see there are various function modules within our search that belong to the same function group. So let's say we don't know the exact function module we want, but we like the look of, say, these here. There's 4 here that are in this ISOC group. Now maybe there are more function modules in this group, but just don't have the word amount in them. So what we can do is close this window and we'll go to transaction SE80. Now SE80, I've mentioned before, is the object navigator. And you'll find that you will use SE80 a lot more than SE38, but we've been using SE38 just to keep focused on ABAP programming itself. SE80 lets you do the ABAP programming, the ABAP editor, but it also lets you go into function modules and all other development objects within an SAP system. So by coming to this drop down, you can see that we can look at all sorts of objects. We can bring up programs. If I double click, we'll see the program over here. Packages, function groups, all sorts of things, classes and interfaces when you get onto ABAP objects, business server pages and so on. And depending how you have this figured, that will determine what comes up in your drop down. So I want to go back to function groups. And we're going to key in ISOC, which was the function group of those 4 function modules that had the word amount in there that we just previously looked at. So I'll key it in, press enter, and then you see the various objects that belong to this function group. And the one we're interested in is function modules. And as you can see, these are the 4 function modules that turned up in our search, but in actual fact, there are a whole bunch of function modules that belong to this function group that may be of some interest. And all we need to do to have a look to see if these are what we want is double click, and we will get to see the code on the right hand side. And just like any normal program, we can test out the function module. Now I'm going to close this window and come back to our previous session. Now the one we're going to work with is actually called spell amount. It's a very simple function module, but it includes everything we want to see when trying to work out how function modules work. So we'll select spell amount and then choose display. And what I'm going to do now is go along each of these tabs and explain what they mean and what's inside and how we use them with function modules. So first of all, we have the function module attributes. Here you can see we have the function group, that this function module belongs to, and we have some text to describe the function module and group. And we have various options further down. Processing type defines the actual type of function module. This one is defined as normal, but we can have remote enabled, which means it can get triggered from an external system. And then the update module, you can see this is set to start immediate, and we have some various other options, such as start delayed. And then just basic information about when the function module was created. Let's move on to the import tab. Now this lists the individual fields we will use as our data interface for data we pass into the function module. So if we look at this from a function module perspective, it's going to be importing information that it can use during the processing of its code. And in this case, we've got 4 fields: an amount, a currency, a filler, and a language. And we have some text on the right hand side that gives some information about what the actual field is. We have a couple of checkboxes. Make them wide enough. The first one is optional. That means with this function module, all of the fields that get imported, they're all optional fields. We don't have to fill them in when we call this function module from our program. More often than not, you will get some mandatory fields, but this one, every field is optional. And then we have pass by value, which means it's going to pass the actual value into the function module. Let's move on to the export tab. Now once the function module does its work, the fields defined in the export tab are what gets sent back to our calling program. So again, from a function module perspective, it exports this information out to whoever called it. Then we have a changing tab. As you might guess, this just lists fields that would be changed by the function module. That is, we can identify fields that we send into the function module. The function module may then change the values, and these fields are then returned back to our calling program. So where the fields on the import tab, the function module only receives in, the export, the function module only sends them back out to whoever called. The changing, it receives data in, changes it, and then sends it back out. So it's a combination of the two, really. Then we have tables. And just like when we looked at subroutines, we're not restricted to just passing in individual fields. We can pass in internal tables as well. And this is where internal tables would be set up. Now the exceptions tab. Every function module has the ability to pass back exception information to indicate if the function module was executed successfully or not. And we're not just limited to finding out if it was successful, but we can also determine specific error messages. So we could have a whole list of exceptions here. And as you can see with this function module, we have not found, we have too large, and we could have a whole host of other messages that get passed back to our program to help us determine why the function module didn't execute as we wanted it to. These exceptions are not fixed. Every function module defines its own exceptions. It's just like passing messages back to the calling program just to indicate if it worked or not, and if it didn't, why didn't it work? So that the calling program can then use its own logic to determine what it should do next. Now the last tab is the source code itself. So this is where a programmer creates the ABAP that processes the data that was passed in. It sends data back out through the export. It can change variables and also update internal tables, and then report any exceptions. So just by looking at this code, you can see some comments here. It's showing you the fields it's importing, the fields that it will export, in this case just one, and any exceptions. programmer in this case starts out with a describe field statement. Then we've got an if statement. And we can just continue down to have a look at the code and try and determine what it does. Now the beauty about function modules that have already been created is we don't need to know what the code's doing, because hopefully we know what this function module should return to us. And in this case, this specific function module, what it does, it turns a numeric value into words. So let's say you had to send out printed checks. Or maybe your program could call this, passing in a numeric value. This would return the value spelled out in words, and then you could output that on the checks. Now, because function modules are created separate to our normal programs, we are given various tools that allow us to test out function modules without having to write the code to call them. So similar to how we would test our program, we are also given the tools to test function modules completely in isolation. We can test a function module by pressing the F8 key once we're in this screen, or just click the icon, the little wrench icon. Now I'm going to step back and step back again, and once we're at the first screen of SE38, we can also test it from this location. Now every function module that you try and test will look a little bit different, because the screen you see is determined from the import parameters, changing parameters and tables. So depending on all those settings, your screen will look different depending on the different function module you want to test. So in this case, we know that all the fields are optional. So we could just test this without inputting any data. And let's do that and see what gets returned. So this is the output. It shows us the input, and then this is what's returned. Seems a bit gibberish, doesn't it? Well, it all makes sense actually, because we get this little button here. And this lets us focus on the results that are being returned by the function module. Now in this case, it's telling us the number 0. Well, we didn't key anything in. Number of decimals is 0, we didn't specify the currency, but look, it has returned the word 0 to us. So actually the function module ran perfectly fine. So now let's key in an amount. And this time let's key in 1, 2, 3, 4, 5, 6. So that's 123,456. We will leave currency, filler and language blank and just execute. Here you can see this was the input and it's returned to us 123,456. So that worked just as we wanted. Now we do have some other options, don't we? We have currency. Let's have a look what happens when we key that in. My currency is Great British Pounds, so I'll key in GBP and then execute. Now this function module this time, because it knows in Britain we have 2 decimal places, it's identified that. Let's focus in on the table that it's returned. So it knows we have 2 decimal places, so it's returned 1,234. And it's treated the 56 as the 2 decimal places. If we chose a currency that again had no decimal places, I think maybe the Hungarian forint, then we're back to the full text. It knows that the Hungarian forint has no decimal places, so we get 123,456. So a very small function module, but you can see it's got its uses, but it shows exactly how we can test a function module in isolation so that we don't have to worry about getting the coding right in our program before ensuring Yep, this is the function module we want to use. And it lets us test out the parameters that we need to fill in very quickly so that when we come to do our coding, we know what fields we're actually going to fill in our ABAP code. Now we have identified the function module we want to use in our program and tested it successfully, let's have a look at how we can call it from our program by using ABAP. So let me step out of the function module builder. I'll go back to SE38, create a brand new program. We'll call this ZMod2. And then we can start coding. Now the first thing I want to do is set up a parameter on a selection screen so I can enter a value. So I'm going to define a parameter. Oops. Let's call it mynum. We'll make it an integer. And what we will do is make the screen look half decent. So let's do selection screen, begin of line. Let's have a comment in there. Start it at the first position for 15 characters. And we'll use a text element. And we have our parameter, and then we'll add in the end of line. Let's see how we look. Looking good, so all we need to do now is define the text. Choose yes to create it. And we'll key in enter a value. Let's activate that. Back to our program, and then we'll activate that as well. And then a quick test just to make sure it looks okay on the screen. And it does. There's our text element, and we can enter a value in there. So back to our code. So now we can enter a value into the screen. What we want to do is pass that value to our function module. But of course we can't do that until we define the code that allows us to call the function module. So instead of just typing in the code straight to the editor, let's use the pattern tool, which is Ctrl F6, or you can click pattern. So as you can see, the call function option is the first one in the list. So all we need to do is enter spell amount, which is our function module name, and click the continue button. And as if by magic, it'll generate this code for us to save us a whole bunch of typing. Now you'll see a lot of the code is commented out. And what I'm going to do, I'm just going to save it and show you why. I'm going to double click on the function module itself to use forward navigation to go to the function module. And if you remember, on the importing tab, all the fields were set as optional. So I'll step back. So when we use the pattern tool, any optional fields, it will automatically comment them out. Then we just need to uncomment them to say we're going to use them. So in our case, we're going to be exporting the amount from our program to the function module. And then inside the function module, it will import that amount into its own variable. So you see, when we call a function module, the actual ABAP statement itself is made up of the word call and function. And then we place the function itself inside single quotes, include all the parameters, and then we have a full stop to terminate this statement. Now note the position of this period. It appears on a line all by itself. And it's there because the system automatically commented out all these optional variables for us. So the system's not going to know what we actually want to fill in and what we don't fill in. If the system put the period up here and we uncommented some of these variables, then we would more than likely get a syntax error, because the period would terminate the statement up here at the end of the first line, and then we would have exporting a list of variables, importing, and so on. For example, if I do this, we get some errors. The system is not expecting the exporting statement. And that's all down to the placement of the period. I could bring it up to here, but I'll just leave it there for now. Oops. Now next, you'll notice the system included an if statement for us. Now the if statement is there so that we always follow best practice and check to make sure the function module was called successfully. Now you'll see that it says if sy sub rc not equals 0. And that's indicating that if it's not 0, there's a problem. And sy sub rc, that specific system variable that we have used previously, will get filled with the values from the exception. So if sy sub rc had a value of 1, we'll know the actual error message was not found. If it's 2, we know the number that we sent into the function module was too large. And if it's 3, it's some other error message that the function module didn't cater for. So always check to see if sy sub rc is equal to anything other than 0 every time you call a function module. So let's add some code. So if sy sub rc is not equal to 0, we don't want to try and output the text that the function module sends to us. So why don't we do something like this? Let's say result equals the function module returned a value of, and then we can include sy sub rc. Oops, what am I doing? I do apologize. I thought I was doing a write statement. Let's do that. Let's do write. Okay, so now we have the write statement, and it's going to write out the error code to the screen if there is an error. Well, the next thing we want to do is to be able to write out to the screen the amount in words that the function module will return to us. So why don't we change this into an else statement? We can say the amount in words is and then we just need to output the variable that's returned to us. Now in this case, the variable that the function module returns is in words, and we see that we've got an equal sign. Well, we need to assign our own variable right here. So let's use one called result. Now, of course, we have to define result. So I'm just going to save the program, do some forward navigation to see how in words is actually defined in the function module. So we can see here it's defined by using the like statement and referring to spell. And you can see spell is actually a structure, and it's made up of all these individual fields. So we can do exactly the same. So back in our code, let's define result like spell. And if we double click spell, oops, oh, looks like I 3-clicked. It takes us to the structure and we can see that our reference is working fine in the program. So now we can uncomment in words, which means when the function module executes successfully, in words will be transferred to our result variable, which is a structure, and we can output it when the sub-RC return code is 0. Now, we need to ensure importing is still there because we're going to be importing the inwords variable and assigning it to result. And also, because result is a structure, the write statement will probably not be able to write out result. It'll probably not be able to do automatic conversion because I remember looking at the structure, it had a mix of data types in it. So I'm just going to save the code. If we have a look at spell, which our result structure is based on, here you can see we have numc, integers and characters all mixed in. So in this case, I think we should get syntax errors. Let's have a look. Result cannot be converted. Yep. So if you remember when we tested our function module, let's go back in and test it. Give it any old number to work with. What actually gets returned is it's like a whole record made up of individual fields. So we have number, decimal, currency, and then word. And word is quite large. If we carry on, another field called DEC word, and then some more. Actually breaking the words up into individual fields themselves. So we are getting returned a lot more than just a piece of text. So we have to cater for that. So I'll step back to the program. And if we look at the structure of spell again, the piece of text we're really interested in is the one that gets assigned to the field word. So that's what we need to write out in our write statement. So back down, where we have result, all we need to do is reference the field inside the structure. And there's one more glaring mistake, or just something I forgot to do. And that's we need to feed in the amount that we're going to fill in on the selection screen. So on the selection screen, we're using the variable mynum. So that's what we need to put here. mynum. Now I think that should just about do it. Let's activate, and then we'll test it out. So we'll use 46,791. and we get the amount is 46,791. We have success. So there you go. That's how you call a function module. It's quite straightforward. And what I would advise is always use the pattern function inside the ABAP editor, because it gives you all the variables to work with automatically. Now from here, you should be able to use any function module that is inside SAP. And just by having so many function modules available to you, you should be able to just more or less copy how existing function modules are set up and create your own.